Hello, this is Ahmed Mashur, Power Systems Consultant. I've been working on AIX more than 15 years for support in systems implementation. In this session, we are going through the AIX security settings and enhancements. So we will start with the AIX security fundamentals, which includes the AIX encrypted file systems, EFS, the role-based access control, RBAC, and the AIX security expert, AI expert. Then we will go through the latest security enhancements in AIX. For the AIX encrypted file systems, did you know that EFS in the encrypted file system is a journaling file system level encryption system that uses the individual key stores? It doesn't work in journaling file system. However, the EFS is working only on JFS too. It enables the file encryption that protects confidential data from attackers with physical access to the computer. And of course, the user authentication and access control can protect files from unauthorized access while the operating system is running, but it's easy to circumvent the ASLs if an attacker gains physical access to the computer. The solution for this is your encrypted file system, which will store the encrypted files on the disks of the computer. In your encrypted file system, a key, just a key, a security key is associated to each user. These keys are stored in a cryptographically protected key store. If you just have done a successful login, the user's keys are loaded into the kernel and, of course, with your process credentials. If the operating system finds a key matching the file protection, the process can decrypt the file key and file content, and the cryptographic information is kept in the extended attributes for each file. Of course. For this encrypted file system, it uses the extended attributes version 2 on the top of the journaling file system, enhanced journaling file system. And of course, each file is encrypted before being written on the disk. The files are decrypted when they are read from the disk into memory so that the file data that is kept in memory is in clear format. The data is decrypted only one time, which is a major advantage. When another user requires access to this file or to a certain encrypted file, the security credentials are verified before being granted access to the data, even though the file data is already. However, if the user is not really entitled to access the file, of course, he will not get this access, and the access is refused, and he will get an error messages for sure. The file encryption doesn't just eliminate the role of traditional access permissions, but it also adds more granularity and flexibility. The other fundamental part in AIX is the role-based access control. Of course, all of us have heard about the access control concept. But the thing is, what if you really want to give a specific authorization or specific role to a user? Not just a permission to do such a task, but it is only for such a command or special task, like, for example, mounting file systems, shutting down the computers, starting such an application. The RBAC is a short form of role-based access control, which is a tool allows the creation of roles, specific roles, of course, for system administration and delegation of administrative tasks across a set of trusted system users. In this RBAC, it provides a mechanism through which the administrative functions typically reserved for the root user can be assigned to regular system users. It is really tracked and very secure and monitored. For any traditional security approach, if you can see here, the slide, like a super user, so he is the super user, I don't have any administrative user, or discretionary access control, which is the DAC, UID and GID, and the special execution for the user and for the group, which is a set UID and set GUID. Like, for example, a password command, for example, password. A root, if a root runs it, you can change other users' password. However, if a normal user just run it, he will only be able to change his password under conditions. The drawbacks for this traditional approach is either to get the access or not to get. So all or nothing access to root commands. Could gain access to root capability via SUID, GUID coded programs. Single owner of file means the administration works if owner needs to be changed. The rule approach we're talking about can restrict which exactly privileged commands or set of commands could be executed. Different users, not only a single user, can have same or different roles. It doesn't depend on SUID and SGID special execution. What is exactly the purpose of this RBAC? It is really delegating privileges and the privileged root operations to regular users. Granular control over system operations. Very extensive use of privileges, no necessary for SUID and SGID as discussed. It provides several predefined roles that can be set up administrative users, which can perform specialized tasks without any need for root user access. Look at this slide. In short, it can give you the definition of the RBAC. Look at this, for example, it can reduce the cost and complexity of security administration by allowing the secure delegation of administrative tasks to non-privileged infrastructures by reducing the need for so many privileged administrators. Or, for example, multiple users are having the root access. Assigning roles to programs can reduce the need of security exposures, of course, such as the use of the security programs. So, to realize the innovation, it's really delegate the administrative duties for system administrators and non-administrative users. For example, look at roles. Users, for example, has a DBA role, so you can access the database located in such disk or such row devices. Or other users have just privileges to print, and others have privileges to do the backup operations. What are exactly the components for the RBAC? The AIX RBAC components are three components: the authorizations, the roles, and the privileges. The authorization is just a mechanism to grant access to commands or functions. We have ready authorizations in AIX, or you can create your own authorization for specific commands run. A role is a container for authorizations that can be assigned to a user. So a user cannot have an authorization. The user can have only roles. The role can have the authorizations. We have also ready-made roles in AIX. You can list them by ls role, and you can create specific role for specific authorizations. The privileges is the something or the attribute that allows you to bypass the security restriction, or that is giving you the exact privilege. Okay, look at this. This is a chart. Number one, if you see in the chart in the right, the AIX command, okay, which is attached to an authorization, is having a privilege. The second thing, the authorization is talking to the roles. So the role is having an authorization, and the user can have more than one role. The privilege is being through the kernel, is going through the kernel itself. After doing that, you have to update the security thing in the kernel. So look at the question. How can a scenario be implemented using the RBAC component? So if you are talking about the procedure, so the answer is, first thing is you create an authorization. And this authorization can be a ready-made from AIX. So you don't have to create it, or you can create a specific authorization, attach it to a specific command itself. After making sure of your authorization, or your ready-made authorization or your customized authorization, you can put them in another container, which is the role. So you create a role and put the authorizations you have. Number 3, you assign the role to the user and you activate it while logging. If the user logs into the system, you can switch on the role and start making these tasks. So the authorization itself is having a specific naming convention. It's like a tree. It is like a tree with a suffix. All of them are starting with AIX, for example. So if you see an authorization AIX.device, so it's something related to devices permissions. If you see something related to AIX.fs, so it is related to file systems, either, for example, AIX.fs.change, so you're changing file systems, AIX.fs.mount, so you're mounting file systems, and so on. So, for example, AIX.system, so it's something related to the system itself, like the installation, the configuration, booting and boot listings, and so on. So AIX, for example, AIX.system.boot is something related to the boot, like changing the boot list. So this is an example, AIX.system.boot.create or .info or .halt or .shutdown. So those are ready created authorizations. So regarding the roles, they are defined in AIX Security roles file. You can list them by role list, the management commands for roles are very easy. The mk role to create a role, change role to modify it, ls role just to list the role, and rm role is just to remove it. This is a real example of a ready-made authorization called AIX to system, something related to the system, .boot, something related to boot, either reboot, shutting down, changing the boot list, and stuff like that. Okay, or AIX to system.boot.shutdown. So since this is a ready-made authorization in your AIX, so you will find it in the configuration file AIX Security private CMDs, privilege commands. If you see the box above, you'll see /etc/security/private CMDs. It is having a command attached to it, which is /usr/sbin/shutdown, because the authorization is AIX.system.boot.shutdown. The init privacy attributes are the privileges, or the kernel privileges itself. The kernel security attributes obtained from the kernel itself. So if you have this ready-made authorization, you just make a role for it. Look at the command number B, user root, will create a role. So mk role, Sandra role, right? And you put this authorization in this role. So once the user log in, he will switch the role on by using the command SW role, switch on role, and you give the role. If you have multiple roles assigned to you and you want to, for example, switch them all, you can run switch role space capital letters all. Then you will be able to do the shutdown command. So, my question now, can I do a custom thing, for example, to do, for example, a CFG just a CFG If, for example, you cannot find it something similar in the authorization, so the answer is simply you will create your own custom authorization by tracking the exact, for example, CFG command. After tracking it, you are tracing its privileges. You will take its privileges, create an authorization, and create an authorization for yourself, attach those privileges to this authorization and command in the CFG command. Then you create a role and assign this authorization to it. And once you create the authorization, you will see it in privacy.cmd's file. And once you create the roles, you will see it in the list of the roles. The other fundamental thing is the AIX Security Expert, which is a security hardening. It's not giving a privilege like the RBAC. It's just doing a security hardening of your AIX file. It is a tool that is part of boss.AIXpert file set. It uses the policy file, and this policy file is an XML file which locks down your AIX. You will choose how would you like to harden your AIX. Highly hardening, medium hardening, low, and so on. So it has various settings like low, medium, high, and secure by default, and so on, and customized, of course. The policy has over 100 rules and tools, such as password aging and lockout and failed logins, SUID programs, disabling services and blocking port scanning. So it is a hardening, so you stop or block unused things or vulnerable things you have. The AI expert can implement the appropriate level of security without requiring great amount of knowledge and then needing to implement individually each security element. It doesn't need a special package to install. It can be used to take a security configuration snapshot. You can use this snapshot to set the same security configuration on other systems. So it can extract your security hardening thing and put that to implement on another system. It really saves time and efforts. It ensures all systems have the correct security and the typical security. It can reduce, of course, in terms of cost, it can reduce the cost and complexity of security administrated by allowing federated management of security profiles across multiple servers. It can enable a more secure IT infrastructure by reducing the effort of maintaining system security. It tracks the functionality, can provide additional security by validating the security profile for each system matches the actual security settings you did. So, in short, it efficiently manages your security hardening across AIX systems. It can control more than 300 security settings from a single console. As discussed, it has several policies: low, medium, high, or Sarbanes Oxley security templates in customized settings to meet business requirements. Security settings can be exported and imported as discussed. The interesting part, the security profiles can be stored in LDAP directory for ease of distribution among the LDAP clients. The other stuff also can be used in an automated environment, like, for example, the Ansible automation. So you can run the AI expert automated to several or hundred AI servers. It has set of commands to run, it has set of scripts, and of course the XML files that store the hardened items. The XML files are used to define set or rules, the rules you are using that define your security level, like low, medium, high. Scripts or commands are used by these roles to set the security options. You can see more details in the following tech notes for settings of AI expert and putting a compliance and generating a compliance report. Now, we are going now to the latest security enhancements in AIX. As you see, we are having 5 interesting parts. Just has been enhanced recently. The trusted execution, the secure boot, the multi-factor authentication, different cryptographic libraries, and the kernel trace in error reporting restriction for, of course, for privileged users. The AIX trusted execution is just a collection of features that are used to verify. The important thing is the integrity. The integrity of the system and implement advanced security policies, which can be used together to enhance the trust level of the complete system. Using the trusted execution mechanism, you'll be able to configure your system to check the integrity of the trusted objects. Okay, so what are the objects that I need to check the integrity for? Like the command, for example. If you have a command with a change it, for example, size, let's change it checksum, right? So to avoid the Trojan horses, a binary file, either it is a library file, a configuration text file, or a script in a runtime. So everything you can check. So it refers to a certificates database, which we call it trusted signatures database. So it works to avoid Trojan horses, for example. While loading this program, while loading this AIX trusted execution, it checks the trusted security database as discussed. by calculating the hash value of the module and comparing it with the value stored in the database. The hash value, which is a security value, and the checksum, of course. If a one bit only change in the file, it will radically alter the hash value for a file. So, if an executable command, for example, doesn't pass the signature comparison, so there is a change in the hash value, it would not run. It will give you a permission, execution permission denied. Doesn't mean a permission. It is a trusted permission. So it used to prevent Trojan horses in tampering with important system files, of course. So to summarize, the trusted execution is used during the installation of files. Install, build, process, and calculate the signatures. Of course, not all files have signatures, only some, but you can sign new binaries with signatures. You can put that, you can add and signing the binaries into the trusted security database. In the offline mode, you can verify signatures on a periodic basis to ensure files have not been altered, like the cron. Integrity verification tool can be run at any time, so you can use cron during the runtime when a certain trusted files are loaded. So we can run it offline, we can run it in a schedule. The other part for the trusted execution is the trusted installation and trusted update. While AIX package signing and verification, okay, packaging for the trusted installation, it covers the package signing and verification while installing them. The signed packages assets may include install, of course, BFF packages, RPM packages, affixes, interim fixes, of course, MKCSPs, and other images, disk images or whatever images. The digital signature catalogs ensure the AIX package relation between different version release modification fixed package incarnations. It also protects against corruption of objects like files, packages, libraries, commands, process breakdown, accidentally delivering the wrong thing, and any malicious intent. For any future interim fixes, service packs, AIX technology levels, it will include signatures. IBM has created signatures that can be validated with AIX, trusted installation, and update policies. The other thing is the secure boot. Since your AIX now is having a trusted execution, it's having a trusted installation, it also has a secure boot. Security during the boot. So it makes sure the virtual machine secure boot or AIX helper extends the Power VM secure boot to AIX domain. The firmware will verify your AIX bootloader and the drivers and the firmware drivers, of course. The boot image itself will include a bootloader signature, the same signature we were talking about. The AIX bootloader will validate your AIX kernel and it verifies the rest of AIX packages files. The secure boot also is built over the trusted execution, yes, which uses the trusted signature database technology, of course. On this case, the early loading of TSD or security database and signature verification is being done. Moreover, cryptographic functions are being added to the kernel. This requires a check on the HMC itself to enable it. The enablement and policy in HMC itself to enable the audit, log error, but continue booting for debug diagnosis. So you can see more details in force to abort the boot when the required boot code fails signature checks. Other stuff is the multi-factor authentication. So it is not just an authentication, it is a multi-factor authentication now. Okay, so we know the normal authentication, the AIX POSIX authentication is doing here. But we can do and we can integrate this AIX with other factors. The process of authentication means establishing with certainty that the person is indeed who they claim to be before granting access to a service or a resource or even a login. The example of authentication in our daily life is like opening a door by using a badge, of course, in offices or so, showing a driving license and an identity card or passport, typing a user ID and a password to log into a computer. In all these cases, the person who must authenticate uses only one type of authentication of their identity. In IT, information technology, providing a username and password is perhaps the most commonly used method of authentication. However, this method has two disadvantages. Usernames can be easily disclosed or shared with people, and a password as well can be shared or subject to brute force or other types of attacks. The AIX itself supports the following authentication methods, which is a very large stuff. Inbound and outbound authentication. The inbound authentication, which is using a method of authentication credentials, are provided by using the same communication channel that is used to access the target service. However, the outbound authentication, when using this method, the authentication credentials are provided by using an alternative communication channel that is different from the one that is used to access the target service. So it is multi-factor. It can be integrated with secure ID, with pliable authentication module, with other tools, with secure keys, with digital keys, with RSA keys, and so on. The AIX can support the cryptographic libraries like the OpenSSL, which has been enhanced recently. The OpenSSH can also be used in the management and deployment of keys and certifications that are used by IBM Power SC multi-factor authentication. The other thing for cryptography is the Cryptolite for SIB library, which we call it CLIck. The CLIck library, it provides the application programmers with a cryptographic primitives that are required for applications that contain cryptographic features. The operating system, the AIX operating system, is really relying on click libraries for features such as the encrypted file systems. Oh, cool. And the network file system version 4, because in network file system version 4 is different than version 3 because it has more security and more access control than even the normal AIX ACL. And of course, the trusted execution. The other thing is the kernel trace restrictions and the RPT restrictions. You can do restrict of the trace facility and give it only to privileged users. For example, in the command, the trace, or for example, the trace report also, you can check that by the trace control trcctl as per the example to enable or disable the trace facility. Also, there is an RBAC authorization ready-made created recently, which is AIX.ras.trace channel 0, which is required to run the trace on channel 0. The same also can be done for the error report command itself. So you can enable or disable this or restrict by the error daemon minus capital R, enable or disable to restrict the error PT. This also has a ready-made RBAC authorization role just been created, just been added to AIX recently, which is AIX.error.errorpt, which is required to run the errorpt command. Thank you very much.